these are the notes for an introduction to GPS. And then the outline of what we'll look at. What really is the GPS system? Why are we using it? How does it work? What do you need to know about it? And then the things that we can do with it. And then I'll show you some things of how we can use it. What is GPS? Lots of people have one in their cars now, but I still don't really think that most people know what it is. GPS is not a single unit. GPS stands for Global Positioning System. GPS was developed by the Department of Defense, or the DoD, and funding for GPS was contingent on making the system available to the public. They weren't going to get any funding to do it if they were just going to use it for military purposes. So that's why it's become so big here in the last few years. GPS is a system. There are 3 major components in the system. If we're missing a single one of them, it doesn't work. There are satellites that orbit all around the Earth. That's why we can use it on the whole Earth. Ground control stations here on the Earth to make it work. And then GPS receivers, or the units, the things that we as the general public actually use to make it work, like what's in people's cars or these handheld things. With the satellites, there are 24 satellites and 3 spares, so there are actually 27. Operational are 24. The DoD knows the exact location of each of the satellites at any given moment. These satellites have very accurate clocks on board, and they communicate back to the people on the Earth, and the DoD keeps track of them that way. And then the control stations. There are 5 control stations to monitor the satellites. I always like to ask, how many are in the United States? We'll see what you see. Without control stations, the accuracy of the system would degrade in a matter of days. These control stations have people that work there that communicate with the satellites in the sky, correct anything that's wrong, and then make sure that way that we who have the units can actually use it. GPS receivers. GPS units are referred to as receivers. They receive information as radio signals from the satellites that orbit the Earth. These radio signals contain important information like a timestamp, the satellite ID number that the information comes from, and then the exact position of the satellite. How the GPS works. If the GPS receiver only obtains signals from one satellite, then it knows that it is located somewhere on the sphere. But if we get 2 satellites, then it can narrow down the location to that yellow area between the 2, almost like a Venn diagram. A mixture between the 2 is going to be in the middle. And if we get 3 satellites, then we can narrow it down between how the circles intersect to one of those 2 yellow dots. But everybody wants to know exactly where they are. So if we narrow it down to 4 satellites, then we can determine exact location. And when we get that 4th satellite, it'll also tell us the elevation of the point wherever we are. Selective availability. SA errors, or selective availability errors, can put you on the wrong side of a stream or even a different city block or street. That's why some of the times when you're using the ones in your cars, they've got you in the wrong place, going the wrong way, and you get really frustrated. 300 feet is a lot of real estate, a lot of area to have a difference for. Sometimes, like in the picture, it shows you might be on one side of the New River and thinking you're on the other side. Other tricks of the trade. Multipath errors. Try to stay away from buildings and other structures when you're using a GPS receiver. This also can be a problem if you're in a city or if you go into a tunnel. Satellites may not be visible because they might be blocked by the tall buildings, and that can give you error. The GPS has worldwide coverage. However, you can lose satellite coverage or receive degraded signals in areas with dense foliage, like if you're in a really heavy forested area, in downtown areas because of the big buildings. You may also lose satellite coverage in deep valleys or gorges because you've got big areas around you that are blocking the signal or could block it. And then the things that we can do with a GPS. We can collect and store points called waypoints. If you're hiking around in the woods and you find a really beautiful waterfall that you want to mark in your GPS receiver so you can figure out how to get back to it another day, that would be a waypoint. And then you can download the points onto your computer and integrate them into other mapping programs. It's possible to use the Sparks to use the GPS and then come back and upload the route that you took using the Sparks onto Google Earth, and then you can see where you walked. Collect and store routes as a series of waypoints. A route is a path between two or more waypoints. The GPS guides you from point A to point B. Maybe you're going to go hiking. You park your car at the parking lot, and you mark that as a waypoint because you want to make sure you can get back there. And then you hike to that waterfall that you found before, and then you need to get back to your car so you can leave. That would be a route. The go-to function, it's actually two separate words. The go-to function will guide you to a predefined waypoint using a compass and a pointer. Again, with the example of the waterfall, if you had marked the waterfall as a waypoint, you could use the go-to function to guide you back to that waterfall. And you can program the GPS to beep when you're within a certain distance of that defined waypoint. What can you do with a GPS? Tide tables. Many of the marine GPSs have built-in tide tables. They will provide tidal information and ranges for any date and any place. Speed. GPSs calculate your ground speed as you walk, run, drive, or fly. If you've ever taken an international flight, some of the time they'll broadcast the speed that you're going, and that's because they're using the plane's GPS. Or there are some GPSs for cars that will beep or tell you when you're going faster than the speed limit. Elevation. In addition to providing you with your latitude and longitude, GPS provides you with altitude information. Altitude is another word for elevation. Current applications of GPS. We can use it for public safety, environmental resource agents, aviation, military, local planning, surveying, recreation, business. When you see the surveyors on the side of the road with that little tube that they're looking through, they're actually looking towards another person way far away trying to get different elevations. And then you can use that in GPS. The future of GPS. Showing a little alien in his spaceship, telling him that that's where we think he might be. And then it says the future is here. The applications are endless. And all of these different things show you GPS units. I find this man very amusing.